So up to this point, any term you can throw out, codons. Where would you find codons? Okay, and what specific type of RNA? In other words, this entire process is called protein synthesis. Okay, so as we look at this, you're saying messenger RNA. Where do we see that specific molecule of messenger RNA up here? The red boxes, that's right. So we're looking at that. That's right here. Okay, and this is all inside of what? What's got this? This is all inside the nucleus. So does DNA leave the nucleus? No, it doesn't. So how do the instructions get from the nucleus out to this structure? Because this is probably what? Where does this protein synthesis take place on? On the ribosome. Okay, so here's your ribosome. Okay, as you correctly said, this is your nucleus. And how do we know that this is DNA and that's RNA? DNA is a double helix, it's double-stranded, and RNA also has what? And it's single-stranded, that's right. So this is again what type of RNA? Messenger, RNA. This entire process, the black in this red or brown or whatever lettering is called what process? Transcription or translation? Transcription. Okay? So a scribe is reading the directions. Okay? And each one of those boxes is a very specific what of messenger RNA. Those are codons. Okay? That is correct. So when this process is complete, notice this messenger RNA takes the message. In other words, like we said before, here's your quarterback. He has the message. He's leaving. This ribosome could then be called what instead? The huddle. Because what happens in the huddle? You get your specific play that tells you where you have to go. That's right. So we've got these very specific codons of messenger RNA. So these are called transfer RNA molecules that physically pick up amino acids and bring them to the ribosome. They get placed in the order that they're specified by what's on the code or codon. So, what are those three-letter segments called on transfer RNA? Anticodon. So, if we were to say just, I don't know, 1, 2, and 3, does 1 go here, 1 goes there, and 1 goes there? But which one is which? Okay, so if we say that, it should be CUU, right? There we go. So number 1 is right here. Okay. Okay. So if we had a table on there to specify for which amino acid that is, does anyone have any questions on how you read and interpret that table? Because if you don't ask, you're telling me that you understand this process. Is there any confusion on how that table on page 207, I think it was? Does anyone have any confusion what we're talking about? This table. I think it was around 200. Yes, 207. This table right here has the amino acids on there. So if you had to list them, you can do that. Going once, yes. Okay. Going twice. So And that's great. You're telling me you can interpret this. So if you don't want to ask, that's fine. Come in on your own time and we'll get you squared away. Or do you want to practice on one? Okay, well, if you want to know, I guess students are asking you to book. They're choosing to do this. If you want to take time, we'll give you a few seconds to get to page 207. And if you don't, that's fine too. $207. Okay, so GAA. That's this middle codon right here, GAA. Okay, remember how we do this. You go to this left-hand column here, find the letter G. Okay, that's the first box you look for. Then you go across the top, and wherever you go across the side, go across the top and go down, and then wherever it is they intersect. Okay, we've got G, A, and A, which it looks to me like it is glutamic acid. Agreed? So CGA, that would be, so C, G, and A, arginine. Okay? So we're getting this understanding. Because you are going to have to do that. And we did that with your exercise with your M&Ms. Okay, fair enough. So, what would happen if, just think of what would happen if we took this thiamine out and give me a separate nucleotide. Okay, so thiamine is supposed to be there, but we put another cytosine there. Okay, so this is supposed to be a T, but now we changed it to a C. That is a very specific mutation. If you had watched that video, if it's occurring in only one spot, it's called a point mutation. That's correct. Okay? So, let's say, for instance, we said it was supposed to be the amino acid, aspartic acid, I believe. Let's see here, this middle one, GAA. No, it's supposed to be glutamic acid. Well, if a point mutation takes place, let's see once what that changes that to. Okay? So this is no longer going to be an A, it's going to be what instead? It's going to be a G. Okay? So, again, this was supposed to be glutamic acid. Now, what amino acid do we have there? GGA. Right, glycine. And just like in the presentation had said, sometimes what could happen, this mutation could result in a stop codon. What's that going to do to the synthesis of that protein? It's going to stop it and keep it from moving on and moving forward. Okay? And that could be as a result of people who can't digest certain materials, or maybe they can't break down other, or it could be blood cells, for instance, or maybe they don't have the correct clotting factors in their blood, because somewhere, along on this line of protein synthesis, a mutation has taken place. And if it's in one spot, we call that a point mutation. That's right. And for the most part, the human body has a pretty good, or your DNA can fix itself. Either that or many mutations are fairly harmless, but some of these can be I wouldn't say devastating, but can be quite harmful. Not all of them. Like I said, for the most part, mutations are dealt with, I wouldn't say simply, but they usually turn out to be, again, harmless. The human body can take care of itself. Okay? But if we change this DNA from one point to a whole segment gets moved, okay? In other words, parts of this codon can get moved up instead. Okay? So the DNA gets shifted just a little bit. And it occurs within an entire frame. You call that a what then? A frame shift mutation. Okay? Anybody have any questions over that? Okay? And I think that's what your presentation had mainly dealt with. Okay? Awesome. Okay? So, again, differences between DNA and RNA. One's single-stranded, one's double-stranded. Okay? Inside the nucleus, replication takes place. Also, if it's in the nucleus and it's messenger RNA, it's which process? If the messenger RNA is reading the instructions, it's transcription. Then the instructions or the code moves to the ribosome and starts assembling these amino acids from this code. Now we're going past transcription, but rather what instead? Translation. Okay? It's where codons of which molecule? These here on the bottom are called what? It's RNA, but which one? Messenger RNA. So then these codons are matching with these anticodons, so these must be called what over here? Transfer RNA. Transfer RNA, all of these, okay? Physically pick up these or assemble these amino acids according to the code, which originally came all the way back here from the nucleus. That's where the directions are found. Okay? So, what are the three types of enzymes we've talked about? No. Enzymes. You got the right idea. You're giving me nucleotides. No.
Oh, helicase.
That's one.
DNA polymerase.
That's two.
And then RNA.
Right. Right. And a good rule of thumb, and it's not always 100% accurate, that you know what suffix do all three of them have in common? Yeah, ASE. Usually that's a pretty good indication you're dealing with a protein. Whether it's lipase, amylase, helicase, any one of those. The majority of them do end in ASE. Okay, so this here on the end, this alligator mouth, we said that was called a replication fork. That's really what you can call it as well. Okay, so you correctly said your DNA helicase, that's breaking. What were these bonds called? Hydrogen bonds. So then there must be another enzyme that puts them back together. It's not helicase, but rather DNA polymerase. That puts them hydrogen bonds back in there. So what enzyme is this that initiates the process of transcription? RNA polymerase. That's right. Okay, and then it was earlier you're talking about your nucleotides that, of course, ATCG, and I think we got that down, right? Adenine, thymine, and so on and so forth. Okay? What else should we possibly note with this? did point mutations, frame shift mutations, talked about DNA, that's a double helix. RNA is a single-stranded molecule, it has uracil. The enzymes, okay? This entire process, from beginning, from here to the ribosome, assembling these structures here from amino acids, which are the building blocks of what? Protein. So this entire process is what? That's what this chapter was about. Protein synthesis. Okay? And also, what else did we want to mention? So we could say that at the very base of this pyramid, if you want to call it that, proteins are very basic. What? These are all coming from individual what? What are all these letters called on DNA? Starts with an N. Nucleotides. So these nucleotides make up amino acids, which make up the proteins. Okay? Or you could say proteins are very basic amino acids, or excuse me, nucleotides that make the amino acids. Okay? So again, DNA can't leave the nucleus. So how do these amino acids know how to assemble themselves together? From the what RNA? Messenger RNA. So where's that messenger RNA found? Is it only in the nucleus? Probably not, because we see it out here too. And these ribosomes are found where inside the cell? If you remember all the way back to chapter 4, what were your 3 parts of the cell? That's one. Not chloroplast, we're not just plants. Cytoplasm, and this has nothing to do with the cell membrane, but notice that your messenger RNA is found in 2 separate spots, in the nucleus and the ribosome, because it has to line up with or get taken those directions to tell these amino acids where it is they need to be lined up. Okay? For a lot of you, whether it's moving on to your post-secondary career of maybe being a power linesman, a wind turbine technician, a diesel mechanic, auto mechanic, any one of those, you're going to have to be able to follow instructions. How many of you like doing what you're told? How many of you absolutely can't stand to be told what to do? If no one can see whose hands are up maybe, but if you can't stand being told what to do, what type of employee is that going to make? Possibly not a good one. Unless you are your own boss. That could be. Yeah, you can be pretty successful. But if you can't take orders or just do the very basics, what's expected of you, what kind of employee is that going to make? And we don't want that for you. We want to make sure we get that through your heads. Okay? So, because I can almost guarantee it, no matter what you're going through after high school, there's going to be certain aspects about your job you're absolutely not going to like. If I'm in the profession I love, yes, that's true, but there's probably going to be things you don't like about your job. So I think anyone would agree I would skip the practice and just go to the game mode every day. Would you agree with that? Or I wish we could just have every day. Football, volleyball, basketball, even when it comes to music, I suppose there's certain times, at least it was when I was in band, you just start playing your musical pieces straight from the beginning to the end. But how many times do you go straight through without having to stop? So, gosh, you flutes are awful. We need to stop. Only the flute section, or the percussion, or the brass. or the offensive line. You're killing us. Or the defensive backs. Or you servers, setters. Okay? Practice. You're always going to have to work on things to make yourselves better. And I think you would agree with that. Okay? So, that's all I have for you for today. We got one more day of this. And tomorrow's a short day because we have an early out. So, tomorrow we'll be going over the essays that you would need to know, which is the process of transcription and the process of translation, and how to assemble these amino acids. So we'll catch up to you next time.